Hello, my name is Josh Reingold, and this is my report on the Oscillation Lab for Physics 2211. The purpose of this lab was to compare the observed and predicted motion of a mass moving on an oscillating spring and evaluate that motion using the law of conservation of energy. The main results are shown here. The primary models used in this experiment are Newton's second law, which states that the net force is equal to the change in momentum over the change in time, the velocity update formula, the position update formula, and the conservation of energy principle. The system in this experiment is the Earth, the spring, and the mass. The surroundings are everything else which do not do work on the system. The initial conditions are the mass of the block and the height and angle at which it was released from rest, or the initial position. Using Tracker, the mass was tracked as it oscillated on the spring, creating data points. These data points were then stored in a table, which was then imported into an Excel document. From there, it was converted to a CSV file for analysis. The shown observations were made based on this data and analysis. This is part of the GlowScript code used in this experiment. It shows the initial conditions being updated to match the data in the experiment. All other conditions in the starter code were updated to best predict the motion of the oscillating mass. It was iterated to improve the computational model and have the closest predictive values. The results included three graphs. The energy graph showed large opposite oscillations in the gravitational potential and spring potential energies. As one increased, the other decreased. There were also small oscillations in the kinetic energy. However, the total energy of the system was conserved, maintaining at a constant zero. The position versus time graph for the x component almost perfectly matched the observed values. However, the y component graphs diverged slightly. Possible errors that might explain this discrepancy include the potential impact of drag or air resistance, as well as imperfections in the observed data caused by tracking errors. What does it mean? The first part of this question asks if the energy principle is satisfied, which it is because even though the potential and kinetic energy change throughout the experiment, the total energy of the system is conserved, maintaining a constant zero. The second part of this question discusses oscillation periods, comparing the observed oscillation times of the x and y components. After measuring these timeframes, it was observed that there was a difference of 0.14 seconds between the two components. This imperfection might have impacted the results of the experiment because it could have affected the force or energy calculations. These errors are also most likely due to air resistance and/or tracking imperfections.